looking at the practice quiz for lessons 5, 4 through 5, 5. And Dustin?
Hey, I had two of them. Did you do number 1 and number 2?
Okay, number 1, when we have to evaluate using the part 2 of the fundamental theorem, they give us an integral from 1 to 6 of 4 over x cubed dx. And so ultimately we need to find an antiderivative for that said function. If we think of 4x to the negative 3 as the way it's in the power form, then we can use our power rule, which ultimately is going to raise our power up 1 and then divide by that new power. So our antiderivative would be 4x to the negative 2 divided by negative 2. So with that simplifying, we'd get negative 2 on top, x squared on the bottom. So ultimately that would be the antiderivative for 4 over x cubed. And again, just keeping in mind here on a quiz or test, if you have extra time, would it be worth your while to differentiate this and make sure you get back to positive 4x over 3? Or 4 over x cubed, I should say. I mean, every antiderivative you could do, you can always just differentiate your result and see if you get back to what you started with. So I would. And ultimately, if we evaluate that from 1 to 6, put our 6 in there, we're going to get negative 2 over 36 minus negative 2. Put our 1 in there. And with that, we ultimately have negative 1/18 plus 2. And they have it as an improper fraction, I believe, here. So ultimately, 2 would be 36/18. So ultimately, we'd get 35/18 then, which should correspond to B. Questions on that one? What else?
The next one's number 2.
And number 2, if we want to find the area of the shaded region, again, the area of the shaded region here, if we were to find the area from pi over 6 to 5 pi over 6 of the cosecant squared, we'd essentially get the white area, if you will. So if we could find that white area, though, couldn't we subtract it from the rectangle and get the dark area? Okay. So really, our setup then, pi over 6 to 5 pi over 6 of cosecant squared x dx, again, would give us the area in the white part. And ultimately, again, the rectangle, we can see that it has dimensions that we can see. We can calculate the area without too much trouble, and then ultimately we'll just subtract what we get here from that rectangle, and we'll have the shaded region. So with that, we need to ultimately, if we want to find this, we need to find an antiderivative for cosecant squared, and ultimately, wouldn't that be negative cotangent? Okay. So if we do negative cotangent x on pi over 6 to 5 pi over 6, we're going to come up with values for those two. So ultimately, if I have negative cotangent 5 pi over 6 minus negative cotangent pi over 6, then that should give us a correct answer, hopefully. But the issue is we got to figure out what is the cotangent at 5 pi over 6 and what is the cotangent at pi over 6. So ultimately, think about our unit circle here. If we're at 5 pi over 6, which would ultimately be at that spot right there, pi over 6 being here, 5 pi over 6 being here. Ultimately, we know cotangent is cosine of 5 pi over 6 over sine of 5 pi over 6. And at that point, we would have a big X, small y. True. So ultimately, that'd be radical 3 over 2 over half. And keep in mind here, there's a negative out in front, but then this would also be negative right here because of the fact that we're in the second quadrant. The cosine value would be negative there. So ultimately, what we get here is going to be positive because it's going to be the opposite of a negative. And so if we divide, we're going to ultimately just get radical 3. So radical 3 would be our result for the negative cotangent of 5 pi over 6. And then minus. And then when we do the cotangent of pi over 6, which is right there, we're going to get the same result, radical 3. It's going to be positive this time, so that means the negative is going to stay as is. So we're ultimately going to get minus that, which ultimately winds up with 2 radical 3. So based on our values for sine and cosine and so on, we can get our cotangent values. If we do so, we should get the area. And again, keep in mind that's the area of the non-shaded part. True? Shaded, the rectangle, that's got the dark and not dark parts to it. It's got dimensions 4 in terms of the height, and the dimension along the bottom is going to be 4 pi over 6, 5 pi over 6 minus 1 pi over 6. So that ultimately would be 2 pi over 3. And so if we multiply here, we get 8 pi over 3. So that would be the rectangle area. So area of the rectangle is 8 pi over 3. And again, 8 pi over 3 minus 2 pi, or 2 radical 3 would ultimately give us approximately what? You notice that, oh, actually no, they don't have approximate answers. They're all there. So ultimately it would be letter C. We don't need to know approximately what it equals because they have the exact answers there. So good. Questions on that one?
Wait, what's the
The area of the rectangle.
oh.
Like I said, in the picture we found the area of the white part by doing the integral. We subtract that from the area of the rectangle, then we'll get our area of the shaded region. What else?
Number 5, 3 times the x squared.
And number 5, we have a trapezoidal rule problem, and it gives us the function 2x cubed from 2 to 8, and we need the subintervals to be, we need 3 of them. All right, so and ultimately we have uniform subintervals here. If we go from 2 to 8, we have 3 subintervals. That means we're going to be going from 2 to 4, and then from 4 to 6, and then 6 to 8 ultimately. 3 subintervals. So with that in mind, we know that our h over 2 part we fill in the blanks in our trapezoidal rule here. When we do the h part here, keep in mind that the h is going to be b minus a over n, which in our case b minus a is 6, and the n is 3, so therefore our h is 2. So therefore we'd have 2 over 2 out here in front. Our y values are going to be at the points in question. The left end point, its y value is, the x value is 2, so the y value, if we plug it into that function, we're going to get 2 times 2 cubed, which would be 16 ultimately. And then the second y value is going to be found when x is equal to 4. And if we plug a 4 in there, we're going to get 64 times 2, that's 128. And the next one's going to be when the x is 6. If we put 6 in there, 6 cubed is 216. And then the final one is when we put 8 in there. If we put 8 cubed is going to be 512. And again, the only ones that get multiplied by 2s are the middle ones. And so if we punch that all out, what do we get? So ultimately that'd be correspond with letter D. Okay, questions on that one?
Wait, why is it 512? Is it times x cubed times 2?
It's a good question. Did we miss one?
It should be 216 for the third one. It should be 432.
Oh, you know what? Okay. I just did the cubes here, didn't I? So, yeah, because we put in, this one we put in 2 cubed, or this one we put in 2 cubed times 2, that's 16.
It's the last ones.
Yeah, 4 cubed.
Two numbers are wrong.
It's just the last 2, right?
Yeah, it's
So it should be 432, and then times 2 would be 1024. Sorry. So it's 2x cubed, not x cubed. So therefore, not 2160. What is it actually?
There's still 2160 here.
Oh, so somebody gave me the right answer regardless. So. All right. So again, the function being 2x cubed, not x cubed. So that's why these are off by a double, if you will. All right. Yeah.
Are you supposed to put from all the y values from 2 to 6 inside that? Right?
Well, ultimately, they're going from 2 to 8.
Yeah.
But we're only doing 3 subintervals. So
Oh,
we're going from 2 to 4, and then 4 to 6, and then 6 to 8.
so
So if we had 6 subintervals, then we would have had to put in 2, 3, 4, 5, 6, 7, 8. Or 12, 2, 2 and a half, 3, 3 and a half, and so on. What else in practice quiz?
Number 6.
And number 6, got similarly though, the Simpsons rule this time. And they give us a function and an interval. And this time our interval length here is 1 because our 2 and negative 2 are 4 apart, n being 4. So our b minus a over n would be 1. So therefore we'd have 1/3. Simpsons rule is h over 3 instead of h over 2. And then again, from here it's just a matter of putting in y values here. So if we put in negative 2 into that expression, we're going to get negative 11 cubed. Negative 11 cubed is what? Okay. And then 4 times, and then we'd need to put in a negative 1 in there. We'd get negative 8 cubed. Negative 8 cubed would be negative 5, 12. And then we do a 2 next. And we put a 0 in. And our 0 in there is going to give us negative 5 cubed, which would be negative 25. And then 4 again. Put a 1 in there this time. We'd get negative 2 cubed, which is negative 8. And then finally, the left end point, we'll put a 2 in there, and we're going to get 1 cubed, which is 1. And so from there, on the screen there, matter of putting it all in the calculator, punch it out, and what do we get?
Negative 1,220.
Which corresponds with letter C. Questions on that one? All right, how about anything else in the practice quiz?
For number 7, which one's like most accurate and which one's least accurate? Like,
Most accurate is always going to be Simpson's rule,
so which one's like,
either left or right. So
so it goes left, right, then like actually Simpsons.
yeah, essentially, yep. So left and right are definitely always going to be the worst approximations out of any of the choices. You wouldn't be able to differentiate between which is worse, left or right, though, unless it would depend on the function. So, but Simpsons is always the best out of any of those. Anything else? Practice quiz.
Can you do number 4?
We want the derivative of that function. Use the first part of the fundamental theorem, which says the derivative of an integral function is the integrand evaluated at the upper limit. So we put in our upper limit into our function. So again, the integrand evaluated at the upper limit times the derivative up the upper limit. So ultimately we'd have times 2, which ultimately would give us 4x squared plus 10x minus 3 times 2. So 8x squared plus 20x minus 6. Should be letter D. So again, key information there though is again it's the integrand evaluated at the upper limit times the derivative of the upper limit. So even if the derivative of the upper limit is 1, like say an x was up there, could we still think of it in those same words? Could we always multiply with the derivative of the upper limit? Even if it was just x? Then we don't have to have 2 different rules. Okay. Anything else? Practice quiz.